And I'm going to invite Jack Jones, who is the chairman of the FAIR Institute and author of the FAIR model and FAIR CAM, to the stage to discuss, quote, overcoming the challenges of mapping NIST CSF to FAIR CAM. And so really quickly, for those of you who don't know Jack, brief introduction. He is one of the foremost authorities in the field of information risk management. He's a 3-time CISO and the author of Measuring and Managing Information Risk, A Fair Approach. And that book was inducted into the cybersecurity canon in 2016 as a must-read in the profession. So Jack, I believe you are good to go. You are sharing your screen and you are pinned, so you're ready to go.
Okay, is this better?
Got it now. All of you.
Okay, so let's dive in. So the title says Overcoming Challenges to Mapping NIST CSF to FAIR CAM. I would submit that maybe a more representative title is Overcoming the Challenges of Measuring the Efficacy and Value, if you will, of the NIST CSF subcategories. And you'll see what I mean as I go along. So hopefully that doesn't discombobulate you too badly, but again, we'll see what I mean as we go along here. So the big question, and I get asked this, it seems like every week by someone, can we take our NIST CSF scores and plug them into FAIR CAM or FAIR and use those scores to do quantitative risk measurement, and therefore in doing that risk measurement, measure their efficacy and the risk reduction done? And I think the answer will become clear as we go along here today, but I get asked that all the time, and that seems to be an item of significant interest because NIST CSF is so broadly adopted and viewed as sort of fundamental in so many security programs that it just makes sense to ask that question. I mean, why can't we take this peanut butter and this chocolate and put it together into something particularly yummy? So let's look at that a little more closely. So for example, let's say we have one of the NIST CSF subcategories, and we want to know how much risk reduction do we get if we move from a 2 to a 3? I mean, that's kind of what we're going for here. And in order to answer that question, there are 2 things we have to resolve. One is, how does that subcategory affect risk? Right? What is its effect on risk? I mean, we all know that backups of information are important and that they should be maintained and tested and all that good stuff. Exactly what is the mechanism by which that affects risk? Okay, and if we can answer that, then what do the scores mean? 1 through 4 score or whatever the case might be. So before we get into that, because I'm not going to assume that everybody here is familiar with FAIR CAM, the FAIR Controls Analytics Model, which is something we just published this fall. So let me cover that very quickly. A couple of terms: controls. These are the things that affect the frequency or magnitude of loss. And here we see some examples that we all know and love. And then control functions describe the ways in which these controls affect the frequency or magnitude of loss. And we see a few examples here. There are actually a lot more functions than this. So a little more explanation. We know that when you combine assets and threats, you get risk, you get the potential for loss. And so we put controls in place. But let's be a little more specific, and let's call these controls, or a subset of control landscape, loss event controls. And these are the ones that directly affect the frequency or magnitude of loss. And we see some examples here. Then we can add another functional domain, which we call variance management controls, that affect the reliability of other controls. And we see some examples here. Right? They affect the frequency and duration of control deficiencies, or what we refer to as variant control conditions. And then we have a third functional domain, decision support controls, that help us make good decisions about all of this. And we see some examples here. Now you can begin to see how variance management affects loss event controls, and decision support affects both variance management and loss event controls. But actually, we have variance management controls that affect decision support controls. So like we audit our policies and that sort of thing. So again, there's a variance management, an example of a variance management control applied to a decision support control. And then we have variance management controls on variance management controls, right? We would audit our vulnerability scanning and the patching practices and those sorts of things. And likewise, we make decisions about that affect other decision support controls. So you begin to see some of the inner workings here of these functional domains and how complex it is. And the thing to note here is that the decision support controls and variance management controls indirectly affect risk. We can't plug a score from one of those directly into a risk equation because it doesn't apply directly. It applies through its effect on other controls. To plug that in directly will inevitably result in invalid results from your application of this in risk analysis. And so, again, I'm not going to go through all of these, but just to provide you a picture, there are 9 different loss event control functions there at the bottom. And you see the key point to this slide is that we have different units of measurement. And that, we'll talk about that again here in a few minutes. But you see that there are these 9 different functions and the different units of measurement for those. And for variance management controls, there are 6 different functions, and we have 2 different units of measurement. And for decision support controls, I'm not going to bother showing a slide on that here now. All of this is available online in the resources in the FAIR Institute. So back to that challenge number 1, how do NIST CSF subcategories affect risk? So if I were to ask a question about, let's take this one, the protect subcategory, how does that affect the frequency or magnitude of loss? Which of those does it affect? And I've had this conversation with people in the past, and the general perception is that the protect affects the frequency of loss, right? And that would seem to make logical sense. And we'll look a little more closely at this here in a moment. But first, if I can advance, again, I wanted to just share that the mapping actually is mostly done, right? There's a first version of the mapping that's been done and is being reviewed and refined, and we anticipate publishing this this quarter. So one of the things, the insights or realizations we gained from doing this mapping is that some of the subcategories in NIST map very simply, right? 1-to-1, like this one, the IDRA3 maps directly to that component of the decision support domain. But many subcategories within the CSF don't map simply. They map to multiple functions within FAIRCAM. And so they affect, the way the subcategory has been defined in this CSF, it is very broad. And as a result, it incorporates many different sort of subcategories, if you will, right? Or control elements that map to different parts of the FAIR controls analytics model, which means this is a challenge in terms of when we take a measurement, say a control like this has been measured, given a rating of a 2, let's say, does that 2 represent the average for all of those different control functions? Is it the best case? Is the worst case? It's that presents a very significant measurement challenge in terms of somehow translating that 2 into actual real measurements, units of measurements. So again, this creates a significant challenge that has to be overcome if we want to eventually be able to take NIST CSF scores and apply them to a risk analysis and have it stand up. And so the mapping breakdown, again, this is based on preliminary mapping that's been done out of the 107 NIST CSF subcategories. Only 24, that's a little bit surprising, only 24 mapped specifically to loss event control functions. right? The things that directly affect the frequency or magnitude of loss. 9 mapped to variance management control functions. 45, again, a little bit of a surprise, mapped to decision support control functions, and 29 mapped to multiple functions across the different domains, okay? So there are 29, at least, again, given the current mapping effort, that present a challenge from a mapping and scoring and translation perspective. And again, keep in mind that the variance management functions and decision support functions, they affect risk indirectly rather than directly. So the scores on those subcategories, again, can't be just simply applied to a fair analysis or translated through FairCam and have the results actually stand up, okay? We have to account for those indirect effects. Which controls are those affecting? Which loss event controls are affected by these variance management and decision support controls, and in what way, and to what degree. And so that's the great thing about this is FairCam provides the answer to analytically applying those measurements through the system, if you will, but we have to get clarity on not only those multiple functional domains, those subcategories that map across multiple domains, but then we also have to get a handle on scoring, which I'll get into here in a minute. So remember my question earlier about the NIST's protect function, and we look at PRIP4, well, that actually doesn't map to the frequency of loss. It affects the loss magnitude, okay? So that's, it's in the protect domain or function of NIST, yet it doesn't affect the frequency of loss. It's really the magnitude of loss. PRIP10, it reduces the duration of control deficiency. So it's a variance management control. And privileged users understanding the rules, that affects decisions. So that's a decision support control. So you can see that it would be a mistake to believe that the way NIST has assigned their subcategories within their functional areas can be sort of simply interpreted as, well, PR must affect the frequency of loss, because clearly that's not the case in every instance. So overcoming this challenge, the subcategories have to be redefined to cover no more than a single control function. Now, I'm not assuming that that's going to happen anytime soon. So we're beginning to sort of break out, again, once the mapping is complete, this will make more progress on this, but we can sort of say, here's how, for those subcategories that map to multiple functions, here's sort of how they break out. Here are the components in there that, if they were analyzed independently, could be assigned to different control functions within FairCam. So the second challenge, what do the scores mean? Okay, so we have to keep in mind there is no standard scoring scale for NIST CSF. Now, I know some people are probably going to go, oh yes, there is. They have their tiers. Those tiers are not intended to be used to score the individual subcategories. They're for evaluating the program. Where does the program sit? Given how everything has been scored in some fashion on the subcategories, where does the program sit? So there is no standard scoring model for NIST CSF, at least that I'm aware of. Okay. Now, maybe there is, and I just haven't found it, but that's my understanding. Right? And that was intentional, as I understand it, because NIST didn't want to pigeonhole the world into sort of their worldview on scoring. And I get the logic behind that, but that presents some challenges and limitations too, in terms of things like benchmarking or sort of solving the problem we're trying to solve here. Consequently, there is a clear criteria on what constitutes a 2 versus a 3 And so a 2 in one organization may not equal a 2 in another organization. So as you can see, this, if we're trying to translate these ordinal scores into some sort of actual units of measurement, these are the kinds of things that have to be resolved, at least if we want the results to stand up. Okay. And so that's sort of half the problem. The other problem is that you can't have a single scale definition for each of the control functions. Now, remember earlier when I said that, for example, in the loss event control functional domain for FairCam, there were the 3 different units of measurement: percentages, time, and dollar signs. You can't have a single scale definition for each of those different units of measurement. And it's actually even more complex than that. We don't have time to get into some of that complexity. But the bottom line is you'd have to have a scale definition for each of the functional domains in FairCam that then you could use to measure the NIST CSF functions by, and then you can begin to make that translation and apply those scores in a rational, defensible way. Okay, so non-trivial sort of challenge here, and we've begun kind of already talked about. So I'll leave it there for the time being, but hopefully you can see some of the challenges associated with those. And so related to that too, what I see oftentimes when organizations are trying to do this sort of thing, it doesn't matter whether they're scoring NIST CSF or ISO or some other framework, they have some ordinal maturity score that they're trying to translate into some sort of non-ordinal range. And this is the kind of thing I see quite often: quartiles or quintiles or that sort of thing, 0 to 25, or it might be 0 through 20 if it's a 5-level scale, that sort of thing. But I would argue that, let's say, something has been scored a 2, which says here that it's working less than half the time, right? I would argue that if, at least when I see organizations scoring things as 2, those things are not working less than half the time. They're working more than half the time, but certainly not optimally, right? So the sort of simplistic approach to breaking this up into quartiles or quintiles or that sort of thing really doesn't reflect reality. I would argue something like this would be closer. And I'm not presenting this table here as a solution. I'm just using it as an example that I suspect more accurately represents the actual efficacy given maturity scores on different control elements and that sort of thing. So hopefully that makes sense. But again, a lot of what I see going on in the industry is more on the table on the left, that very simple to understand, but I would argue profoundly inaccurate in most cases. And the other challenge is, as I mentioned, not everything is efficacy is a percentage. You have units of measurement other than that, time being the most common alternative unit of measurement. And the other thing I would point out is that maturity is not really the same thing as efficacy. Are they related? Yeah, absolutely they are. But I think when I think of this kinds of scoring I see on maturity models, that's different. And I think the 2 tables here kind of hopefully reflect that to some degree, that maturity score does not necessarily reflect efficacy. So at least not sort of simply as on the left. So something else to keep in mind there has to be wrestled to the ground if we want to be able to do this and have it stand up. So as I said, we have to define ordinal scale scales for each of the control functions in order for us to begin to make these sorts of translations. Oops, why is it going backwards? Shouldn't do that. Okay, so wrapping up. Again, this is what we want to be able to do. And it makes perfect sense, again, because of how widely used NIST CSF is. And we want to be able to prioritize this stuff and know what to focus on first and what kinds of solutions are going to have the greatest ROI. What you have to do first is redefine the subcategories. And when the mapping is through, that effort will begin, right? So, and not redefining necessarily, but again, break those NIST CSF subcategories that cover more than one NIST or FAIR-CAM, too many acronyms, FAIR-CAM control functions will be broken out so that we can, not have the confusion and munging together of measurements that create all sorts of problems analytically and from a results perspective. We're reaching out to NIST to offer assistance if they want to undertake something like this. Voices from the community would be wonderful to help us gain traction here. But we're not waiting. Again, as I said, when the mapping is done, we'll begin breaking it out. And even if NIST chooses not to undertake something like this, that decomposition would be available to the community if organizations wanted to apply. And then we have to develop ordinal measurement scales for FAIR-CAM functions, and these are already underway. So more to come on that. So I'll stop there. Hopefully that was halfway enlightening and maybe some surprises in there. And hopefully there's some questions. I can't hear you, Luke. You're on mute.
Thank you for that. Thank you, Jack, for your presentation. And looks like we've got some comments about folks who are also going to be reinforcing some of the recommendations that the Institute's going to make on to NIST and some of the work there. So you got some folks saying that they're providing comments along similar lines. So we have a couple minutes here left in our allotted time for Jack. If you have any questions, please throw them in the chat. Jack, I just, as one kind of question, want to see kind of what the path forward looks like. If you could talk a little bit more when it comes to FAIR-CAM, the mappings, and maybe just in general for the rest of the year, give people a little bit of the road ahead for 2022.
Sure. So we have a number of mapping initiatives. So there's NIST CSF, there's CIS controls, there's NIST 853, there's ISO, there's high trust, there's FFIEC, CAT. I think that's everything going on right now. So as those get wrapped up and reviewed, they'll be published. There'll be white papers and probably spreadsheets of the mapping and that sort of thing that are published for people. Then we also have an initiative being kicked off for sort of use case development that will include the application of sort of these mapping resources and whatnot. We continue to work on white papers, how to use and apply FAIR-CAM, both in the context of these mapping exercises, but also outside of that as well. So, more and more as the year goes on, we'll have more and more published. We also expect by mid-year to have sort of an ability to demonstrate the application of FAIR-CAM quantitatively. So that should be, I think that'll blow the socks off some people in terms of seeing what this can actually do analytically. So I guess that sort of sums it up.
Yeah, absolutely. Sounds good. One last question here about, and Nick is also answering in the chat, but since we have a minute left, thoughts on developing quantitative metrics in national security systems where dollars are not a valid metric for losses. And I know we've had conversations in the past about with some organizations, but want to just hear from your perspective.
Yeah, absolutely, and I certainly understand it. And there's actually a pretty straightforward way of dealing with sort of the effect on the mission instead of measuring impact in dollars, which I would argue is still very effective in the government circles too. There's also an approach, I haven't published on it yet, but there is an approach to measuring the effect on mission that I think will resonate really strongly with folks. So as I'm able to come up for air, I'll hopefully be able to publish on that too sometime.
Awesome. Well, thanks, Jack. We look forward to the future of FairCam and more of your thoughts and publishings later this year and onward. So with that, everybody, we're at the halfway point of our event today. We're going to take a quick 10-minute break, give everybody a chance to refill their water bottles, get some coffee, maybe get some lunch or a snack, hit the restroom, and then we're going to be back here in 10 minutes at 12:50 p.m. Eastern time. And I'm going to throw the agenda up on the screen sharing in a minute so that we can see it all and go through everything. As we continue on to the second half of the presentation, we're going to come back with the information security team from Thrive Financial. Rich and Andrew are going to walk through a sample analysis of an MFA outage. So no need to even leave the Zoom. Feel free to just keep yourselves muted, minimize. I'll come back on in about, I got 9 minutes. I'll be back on in about 7 or 8 minutes, get us kicked off again, and hand it over to Rich and Andrew. So with that, we are now officially on a break. Let me just share my agenda slide with everybody so that you can see the times. So yeah, so we'll be back in about 10 minutes. Thanks, everybody.